Today we're going to talk about the tangent and the cotangent functions. And at the very top of the paper on secant and cosecant, I actually had the same sentence here, which is that tangent and the reciprocal trig functions are all based on sine and cosine. So if we can learn the sine and cosine, we can figure out the rest of them. We don't need to sit down and memorize them. Now, if memorizing is your thing and you love memorizing, go to it. Let me say that I do not have them memorized. I figure them out. I suspect that many math teachers don't have them memorized. They figure them out. But the one thing that you might need to memorize is that tangent is sine divided by cosine. That's the one thing. Sine divided by cosine is tangent. And if you know that, I actually can't always remember that part, but what I do remember is that cotangent is cosine over sine. And cotangent starts with C, and cosine starts with C. That's what helps me remember the definitions, because it's either sine over cosine or it's cosine over sine. So I actually remember the cotangent, and then I take the reciprocal for the tangent. But again, tangent is sine divided by cosine. And the next thing is down below here, you've got your unit circle, so we can kind of look at this. But when we go to tangent of 0 to figure it out, our unit circle here, tangent is sine, which is the y value, divided by the cosine, which is the x value. Tangent then is going to be 0 divided by 1. When we fill that in, and 0 divided by 1 is simply 0. We can do the same thing with pi over 6. And nice that you can just look down below in your paper, pi over 6. Well, what this is going to be is it's going to be sine over cosine, and if you would like to write down the computations, I would recommend getting out another piece of paper and writing them down. Because I can squeeze them in. I have a little bit more space than you, if you would like to write them down. But in this particular case here for the pi over 6, as I go back, I've got the space underneath that you don't have. And what it is it's going to be 1/2 divided by, and so it sounds like people are getting their papers out, so I'm going to write this a little bit better. So tangent of pi over 6 is going to be the sine value of pi over 6, which is 1/2, divided by the cosine value, which is radical 3 over 2. And when dividing, don't ask why. Flip the second one and multiply. So this becomes 1/2 times 2 divided by radical 3. And when we multiply fractions, we multiply the tops of the fractions together, and we multiply the bottoms of the fractions together. And 1 times 2 is 2, and 2 times square root of 3 is 2 square root of 3. But we can simplify this right here. The 2's cancel out. So this is really 1 divided by radical 3. And some of you are thinking, oh no, after all that, we still have to rationalize the denominator, which is true. We don't like having a radical in the denominator, so we need to get rid of the radical in the denominator. And we're going to multiply by a fancy form of 1, which is radical 3 over radical 3. We get radical 3 over the square root of 9, and what does the square root of 9 equal? 3. Radical 3 over 3. For tangent, a little way to remember a little trick that I just learned last year. Pi over 6, well, what's 3 plus 3? 6. Maybe works for you, maybe doesn't work for you. It's working for me really well, and I have to sit down and memorize tangent. So there's a little trick. Again, the denominator of 6, radical 3 over 3, because 3 plus 3 is 6. If we look at tangent of pi over 4, it won't be nearly as complicated on this one. Go into our unit circle because we can. It's on our paper here. It's sine, which is the y value at pi over 4, divided by the cosine value at pi over 4. So tangent, when we look at this, is going to be the square root of 2 over 2 divided by the square root of 2 over 2. Well, the square root of 2 over 2 divided by the square root of 2 over 2 is 1. And there's our value. We didn't have to do a lot of extra math there. Tangent of pi over 3. Well, the tangent of pi over 3, when we look back at our unit circle, because we can, once again, it's going to be the y value at pi over 3 divided by the x value at pi over 3, because it's sine divided by cosine. Tangent is sine divided by cosine. So in this case, for this one, it's going to be the square root of 3 over 2 divided by 1/2. When dividing, don't ask why. Flip the second one and multiply. So we get radical 3 over 2 times 2 divided by 1. When we multiply fractions, we multiply the tops together and we multiply the bottoms together. And we get 2 times the square root of 3 over 2 times 1, which is 2. Once again, we can simplify those two values. 2 divided by 2, the square root of 3. That's going to be our tangent value. I'm still deciding if this is a good memory technique or not, but it's pi over 3, and tangent of pi over 3 is just radical 3. So the 3's kind of go together. I like my pi over 6 better. 3 plus 3 is 6. But again, that might work for you as a memory technique, and it might not work for you as a memory technique. We have one more, the quadrantal. So let's look at our unit circle because we can. And once again, at pi over 2, we're going to take the y value divided by the x value. So tangent of pi over 2 is going to be 1 divided by 0, which could also be written as 1 divided by 0 like that. And what do we get when we divide by 0? We get undefined. When 0 is underneath, the function is undefined. I'll have to abbreviate here just to fit that in. Now, when we go to cotangent, the cotangent, same idea. This one is cosine divided by sine. But ultimately what happens on this is we're going to take the reciprocal of this value. And the reciprocal of this value then is going to be 1 divided by 0. And we just saw that 1 divided by 0 is undefined. And we will expect you to write undefined, not 1 divided by 0. So when we look at the cotangent of pi over 6, what this is going to be is it's going to be the reciprocal of tangent. We still could do the cosine value divided by the sine value, which in this case, the cosine value at, looking at our unit circle, the cosine value would be the square root of 3 over 2 divided by 1/2. And if you look down below where you were writing this down, we've done the math already. We did it with respect to the tangent of pi over 3, but it's still the same computation. Square root of 3 over 2, that's the cosine value, and then divided by 1/2. So the cotangent, when we take the reciprocal of the square root of 3 over 3, is just going to be square root of 3. It's written down below, once again, in terms of tangent of pi over 3. Cotangent of pi over 4. Cosine divided by sine for cotangent but the reciprocal of 1 is still 1. Cotangent of pi over 3. Well, again, I'll refer to the unit circle. Cotangent of pi over 3 is going to be 1/2 divided by the square root of 3 over 2. We've already done that math in reference to the tangent. So we just have to find our work, 1/2 divided by the square root of 3 over 2. And it is in green. And ultimately what we ended up with here, and I'm going to write that a little bit better, add one thing in there, is the square root of 3 over 3. So here's going to be the square root of 3 over 3. And then finally, the cotangent. Cotangent is going to be cosine divided by sine. So down here for the tangent of pi over 2, we did 1 divided by 0. For the cotangent of pi over 2, it's going to be 0 divided by 1. If you prefer to write it in this format, that's fine. We can do that calculation. 0 divided by 1 is 0. So in terms of memorizing again, just from my perspective and maybe a couple other people's, I learn tangent and then I apply it to cotangent. I don't have any tricks to remember cotangent. Because once again, for the tangent of pi over 6, 3 plus 3 is 6. The tangent of pi over 3, the 3's, it's just the square root of 3. Maybe not the best method, but it works for me. And then I just apply it. I take the reciprocal of the functions. Notice some of the patterns in there. Like I said, we referred back to the math when we were doing these different computations for cotangent, and we didn't even have to do any of the extra work. But as we look down below here, taking a look at this box, earlier in the week, we had done some notes where we talked about all students take calculus. That's the mnemonic. That's the memory technique to help us remember that in the first quadrant, all of the functions are positive. So tangent and cotangent are definitely positive in the first. And where they're positive, where else they are positive, is going to be in the third quadrant. All students take starts with T, tangent starts with T, so 1 and 3. And consequently, if they're positive in quadrants 1 and 3, then they're going to be negative in quadrants 2 and 4. So we still need to be able to identify what quadrant are we working with. And if we can identify what quadrant we're working with, then we can identify, are we working with a positive or negative value? So to summarize, and I only did the tangents this time, but when tangent is 1, then the reciprocal, which is cotangent, is 1. When tangent is 0, we take the reciprocal of 0, so our cotangent is going to be undefined. When tangent is the square root of 3, when we take the square root of 3, then we end up with the square root of 3 over 3. And let me just go up and check my work here for a minute, looking at the chart. Because here we're given tangent is square root of 3, so when we take the reciprocal, we get that. So when tangent of theta is the square root of 3 over 3, then cotangent's just going to be square root of 3. And finally, when tangent of theta is undefined, the cotangent is going to be the reciprocal there, which is 0. Kind of a recap of what we just did. So as we get close to finishing here with the notes, looking at our unit circle, just like the secant and the cosecant notes, there's really not a lot of space to write here, but I am going to try to go through here a moment and at least do some tangents. Once again, what I want to stress to you is that if you know the first quadrant of tangent, then the only thing that's going to change in terms of the values is whether the value for tangent is going to be positive or whether the value for tangent is going to be negative. That's the only thing that changes if you really look at the unit circle patterns here. So once again, when we started these, what we had for tangent here is that the tangent of 0 is 0. And then at pi over 6, the tangent of pi over 6, and you really need to write very small on here, conceivably, to fit this in. But the tangent of pi over 6 then is radical 3 over 3. Once again, 3 plus 3 is 6. And the tangent of pi over 4, and you can look up there at your chart, but you see that the tangent of pi over 4 is 1. And the tangent of pi over 3 is going to be the square root of 3. And the tangent at our quadrantal at pi over 2 is undefined. I'll probably have to abbreviate that. So I want to stress again that as we continue to go around this unit circle here, the issue on this is that tangent of 2 pi over 3, our next value, is going to have the same numerical value as tangent of pi over 3, which is the square root of 3. But in the second quadrant, which is where we are now, it's going to be negative the square root of 3. And tangent of 3 pi over 4 is 1, except that in the second quadrant, tangent's negative. Same values, the 3 pi over 4, the 5 pi over 4, the 7 pi over 4, they all link back to pi over 4. The reference angle is from the first quadrant. Tangent of 5 pi over 6 is going to be the square root of 3 over 3, except that in the second quadrant, tangent's negative. And if you're really with me, you get this. It's not changing. Same idea for sine and cosine, same idea for secant and cosecant. Tangent of pi. You might have to do this one. But tangent of pi is sine, which is 0, divided by cosine, which is negative 1. And what's 0 divided by negative 1? 0. You could think of it in terms of symmetry. Tangent of 0 is 0. If we fold our unit circle hot dog style, then this value is going to land over here. It's reflecting over the y-axis. But since tangent of 0 is 0, so is tangent of pi. That idea works for tangent of pi over 2. If we fold this over hamburger style, then tangent of 3 pi over 2, getting a little bit ahead of myself, but tangent of 3 pi over 2 is also going to be undefined. It was undefined up top of the unit circle. When we fold it over, it's still going to be undefined. If you don't believe me, then you do negative 1 divided by 0. And when we divide by 0, when 0 is underneath, the function is undefined. But back to our not quadrantals, the 7 pi over 6. Tangent of 7 pi over 6 is, well, you look over here at pi over 6, you see that it's radical 3 over 3. In the third quadrant, tangent's positive. 5 pi over 4, tangent of 5 pi over 4 links back to pi over 4. Tangent of pi over 4 is 1. So is tangent of 5 pi over 4. Tangent is positive in the third quadrant. tangent of 4 pi over 3. Well, tangent of 4 pi over 3 links back to the tangent of pi over 3. It's radical 3. The tangent's positive in the third quadrant. We just did the quadrantal a few minutes ago. As we finish this unit circle here, tangent of 5 pi over 3. It's going to be the square root of 3, except that in the fourth quadrant, all students take calculus. Tangent's going to be negative because cosine is the positive function in the fourth quadrant. And tangent of 7 pi over 4 is 1, except that we're in the fourth quadrant. We're in the fourth quadrant. Tangent's negative. And tangent of 11 pi over 6 is going to be the square root of 3 over 3, except that we're in the fourth quadrant, and in the fourth quadrant, tangent is negative. And as we go full circle here, tangent of 2 pi is 0. I'm not going to take the time to fill in cotangent. We don't have enough space to write on our papers anyway. But let's turn over here and let me just get you, I hope, going in roughly the right direction on a couple of these problems here. And it's the same idea behind it as we did with our secant and our cosecant, but it's the tangent of 11 pi over 6. Well, tangent of 11 pi over 6, it's pi over 6. So you can use your hand gesture. Oh, no, that's not going to help me. But if you want to do sine over cosine for tangent, you want to use your hand gestures. But since it's pi over 6, square root of 3 over 3. 3 plus 3 is 6. Is how I remember it. We can do, oh, I'm going to struggle here with that. The pi over 6, which is going to be square root of 3 over 2 divided by 1/2. It is the computation. You get that if you want to do sine divided by cosine. But the other thing is, what quadrant is 11 pi over 6 in? And hopefully you're thinking 4. Is tangent positive or negative in the fourth quadrant? It's going to be negative. As we look at number 2 here, this one's cotangent. And the way that I think of it is the same way that I think of the secant and the cosecant. What does cotangent link back to? It links back to tangent. It's the reciprocal function. And I do know my first quadrant values for tangent. Tangent of 5 pi over 4 is 1. Sorry, tangent of pi over 4 is 1. If you want to do the sine divided by the cosine, it's the square root of 2 over 2 divided by the square root of 2 over 2. But once again, what quadrant is 5 pi over 4 in? Well, quadrant of 5 pi over 4 is quadrant 3. The numerator is 1 bigger than the denominator. That's how I know that. So is tangent positive or negative in the third quadrant? It's positive. But lastly, what we need is we need the reciprocal of 1, which is 1. Now I want to jump down to finish today with problem number 9. It seemed to give us some trouble with the cosecant or the secant. I can't remember which one it was, but it's the same value here. It's cotangent of negative 5 pi. And once again, I still look at this from the standpoint, well, what's the tangent of negative 5 pi? Negative means the direction that we're rotating when we're looking at this unit circle. I actually prefer to draw a picture And when we start here, this from here to here is 1 pi. From here to here is another pi. So there's one circle, which is a distance of 2 pi. 3 pi. 4 pi. 5 pi. We end up right there. What's the ordered pair at that point? It's -1, 0. And tangent is going to be 0 divided by -1. Sine divided by cosine. That's what tangent is. But I chunked myself on space. But to answer this question here, cotangent is the reciprocal of that, which would be -1 divided by 0. So when we fill in that answer, what are we going to write? Hopefully you're thinking undefined, which I abbreviate.